Hello, my dear students. Today we are going to discuss alkenes, which is unsaturated hydrocarbons. We are going to discuss their nomenclature, and we are going to discuss ethylene gas in details and its physical and chemical properties, and we are going to discuss the economic importance of its polymers. So let us start. Saturated hydrocarbons or alkenes. Alkenes are hydrocarbons having the general molecular formula CnH2n plus 2. So we have good reasons in this point. Alkenes are saturated hydrocarbons because all their bonds are sigma bonds and have no pi bonds between the carbon atoms. The first members of alkene family, here's the name and the formula, methane CH4, and the structure formula is CH4 also, ethane CH3, CH3 the structure formula, and the molecular formula C2H6, and propane the structure formula CH3, CH2, CH3, and molecular formula C3H8, and butane structure formula CH3, CH2O2, CH3, and the molecular formula C4H10. Remember, my dear student, here the general formula for alkane CnH2n plus 2. The nomenclature of alkenes. The name of alkene is determined according to the longest continuous chain and on the number of its carbon atoms. As shown on the screen, the root name is pentane, and here, as shown on the screen, the root name is hexane, and the carbon atoms are giving number in the longest chain, and if the longest alkane chain free from any branches or side chain, the carbon atoms are giving numbers from any side, left or right side. As shown on the screen, it will be normal butane or N-butane, and here also is called normal pentane or N-pentane as straight chain without any branches. If the longest chain here attached to an alkyl group or any other atoms, the numbering of carbon atoms in the alkane chain begins from the side which is nearer to the branch, and the nomenclature begins the numbering of the carbon atom from which the chain arises. Then the name of the branch and ending by the name of the alkane, such as the example shown on the screen, it will be 2-methylpentane, as the chain here near to the carbon number 1. And another example, here the longest chain is 6 carbon, so it will be 3-methylhexane. And if the side group is repeated in the alkane chain, so we use the prefix di or tri or tetra to indicate the number of repetition. Here, as shown on the screen, 2,3-dimethylpentane, and another example here, 3,3-dimethylpentane. And if the branch is a group such as chlorine, bromine, nitro, the name of this group is ended by the letter O, so we say chloro, bromo, or nitro. As shown on the screen, it will be 2-bromobutane, and another example here, it will be 2 and 3-dichlorobutane. If the side group are different, alkyl group and halogens, for example, the groups are arranged according to their alphabetical Latin names, after numbering from the end, that giving the branches the least possible summation. As the following example here, it will be 2-bromo-3-methylbutane, and another example here, 2-bromo-3-chlorobutane. And another example here, it will be 3-ethyl-2-methylpentane, and here it will be 2-bromo-3-ethylpentane. Remember, my dear student, you have to look for the longest chain first and numbering it beside the carbon of the nearest to the branch, and if the branches here contain alkyl and foreign atom, we have to start with the end that near to the foreign atom, not from the alkyl. Here, this example, it will be 2-bromo, 2-chloro, 1,1,1-trifluoroethane. Now, my dear students, we are going to discuss methane in details that has molecular formula CH4. Here, the methane represents 90% of the natural gas under the Earth's crust or accompanied to petroleum. Here, methane gas is called the gas of swamps, and we have given reason for this point. The reason for that because it goes out as bubbles in swamps produced from decaying organic wastes by bacteria. Here, my dear student, methane is found in the atmosphere in a small ratio as 0.00022%. Now, my dear students, we are going to prepare methane in lab. This process of preparation is called dry distillation for anhydrous sodium acetate with soda lime giving methane. The soda lime, my dear student, is a mixture of caustic soda, which is sodium hydroxide, and quicklime, which is calcium oxide, as their molecular formula NaOH and CaO. As shown on the screen, here the reaction between anhydrous sodium acetate and soda lime gives the methane gas, which is collected above water as it doesn't dissolve in water, as shown in the following animation. As shown in the animation here, if we put the anhydrous sodium acetate and the soda lime, and by heating them, we found that the methane gas is produced and be collected above water as it is insoluble in water, as shown in the screen. As the equation proceeds, CH3COONA plus NaOH gives, by heating and the presence of calcium oxide, it gives CH4 plus Na2CO3. Now, my dear students, we have good reason in this point. The using soda lime is better than caustic soda in preparing methane. The reason for that is the calcium oxide, which is the difference between soda lime and caustic soda, that the presence of calcium oxide, which is quicklime, in with caustic soda that forms soda lime, it reduces the melting point of the mixture and absorbs water vapor to get dry methane. And we have another give reason in this point. Methane is collected by downward displacement of water. The reason for that because methane gas is lighter than water and insoluble in water. Now, my dear students, we are going to discuss the physical properties of alkanes. The first four compounds are gases from carbon number 1 to 4 carbon atoms. And the methane gas is a fuel for houses. While if we get propane and butane in compressed cylinders, we use them as fuel called butagas in houses. My dear student, notice that in cold places, propane ratio increases than butane in the butagas cylinders, while in hot places, butane ratio increases than propane. My dear students, the alkanes which contain 5 carbon atoms till 17 carbon atoms are liquids of low boiling point as kerosene fuel. My dear students, also notice that when the alkane compound contain more than 17 carbon atoms, they are solids as paraffin wax. We have good reason in this point, my dear students. Alkanes are insoluble in water. The reason because alkanes are non-polar compounds, so can't solve in the polar solvent as water. Here, another good reason, my dear student. Metals are covered by heavy alkanes such as paraffin wax or kerosene. The reason for that because the insoluble in water, so protect them from oxidation and rust. Now, my dear students, we are going to discuss the chemical properties of alkanes. So we have give reason in this point. Alkanes are chemically inactive don't react with sodium or oxidizing agent, as the following animation will show. As shown in the screen, permanganate remains as it is. So my dear student, the alkanes are inactive because all their bonds are sigma bonds, which is difficult to be broken on this strong bond. Now, my dear student, we are going to discuss the burning, which is the combustion with oxygen. Here, alkanes burn in oxygen, giving water vapor and carbon dioxide, releasing large amount of heat, as shown in the following animation. Here, my dear student, dioxide and water as shown on the screen. So, my dear student, these reactions are highly exothermic and used as fuel. As the equation proceeds for combustion of methane gas, CH4 plus 2O2 gives carbon dioxide and water vapor and large heat. Now, my dear students, we are going to discuss the halogenation process. It means the reaction of methane with halogens. Halogens means fluorine, chlorine, bromine. So alkanes react with halogens by heating up to 400 degrees Celsius or in the presence of ultraviolet rays in series of substitution reactions, and the product depends on the type of the halogen and the alkane used, as the following animation show. As shown on the screen here, this is the methane gas, and we are going to react it with chlorine. Here, the bond between the chlorine atoms will be broken, and the bond between carbon and hydrogen of one of the 4 carbon and hydrogen atoms are broken, and so it will form CH3Cl, and HCl will be formed. Here, this is a substitution reaction, as the hydrogen is replaced by chlorine, forming CH3Cl and HCl, which is the product of the reaction. And the reactions will be continued, as we are going to show later. Here, my dear students, the CH3Cl react with another molecule of chlorine. Here, the hydrogen atom also is replaced by chlorine atom, and so it forms CH2Cl2, and another molecule of HCl will be produced. And the reaction will be continued, as the hydrogen atom will be all replaced by chlorine atom. Here, my dear student, the reaction depends on the ratio between the methane and the halogen, as the reaction proceeds in the following screen. CH4 plus Cl2 in the presence of ultraviolet radiation. It will be CH3Cl and HCl are produced. Here, CH3Cl is called methyl chloride or chloromethane, and the reaction continues by replacing by another hydrogen atom, forming CH2Cl2 plus HCl, forming methylene chloride or dichloromethane, and the reaction also is continued until the removal of all hydrogen atoms. Here it forms CHCl3 plus HCl, which is chloroform or trichloromethane, and the reaction will be continued also, as releasing one hydrogen atom also, that's the last hydrogen atom present, forming CCl4, which is called carbon tetrachloride or tetrachloromethane, and HCl also is produced. Now, my dear students, we are going to talk about the uses of halogenated derivatives of alkanes. Here's the name and the formula and the uses. The name, which is chloroform or trichloromethane, as shown on the screen, CHCl3, here, or molecular formula CHCl3. Its use is used as an anesthetic substance, but its use was stopped, and we have give reason for this point, because the inaccurate estimation of the dose for each patient causes death. Another molecule for halogen derivative of alkane, which is halocene, or 2-bromo, 2-chloro, 1,1,1-trichloroethane. Has the structure formula as shown on the screen: CHBrCl, CF3. Here, as we know, the use of this compound is anesthetic substance like chloroform, but it is safe. It doesn't cause death for the patient, as so it is used now instead of chloroform. Another compound for halogen derivative of alkane is 1,1,1-trichloroethane. Its structure formula as shown on the screen: CH3, CCl3, and this compound is used in dry cleaning. Another compound here, which is ferrium, CF4 or CF2Cl2. Ferriums, my dear students, are compounds containing chlorine, fluorine, carbon compounds. The most famous one is that as shown on the screen, CF4 tetrafluoromethane or dichloro-difluoromethane, CF2Cl2, and this is the most type of ferriums. And their uses: they used as air condition or fridges as cooling agent, and they can be used as rushed substance to liquid or perfumes, and are used as cleaner for electronic sets. We have given you in this point, my dear student. Ferriums are used in large quantity as cooling agent. The reason for that, due to its cheap price, easily to be liquefied, and non-poisonous, and no corrosive for metals. Another good reason for this point: there is an international agreement to prevent the use of ferriums in starting from 2020. The reason for that, because ferriums cause the decay of the ozone layer, which protects the Earth against harmful effect of ultraviolet rays. Now, my dear students, we are going to discuss the thermal catalytic cracking. It is converting the heavy long petroleum chain to lighter short chain, as the following animation will show. As the animation shows, my dear student, the cracking of long chain as shown on the screen, here the alkane that produce alkane and the alkene. So, my dear student, this process for cracking takes place during refining of petroleum oil and to obtain gasoline for car fuel, or ethene and propene in the manufacture of polymers. And this process, my dear student, takes place by heating the heavy petroleum products under high temperature and pressure in the presence of a catalyst. For example, here, my dear student, the octane C8H18 by thermal catalytic cracking under high temperature and pressure, it gives butene C4H8 and butane C4H10. My dear student, notice that we can make a question for this: how to obtain alkene and alkane from alkane. The answer for this question is to write the equation here of octane that by thermal catalytic cracking under high temperature and pressure gives butene and butane as shown on the screen. Now, my dear students, we are going to discuss the economic importance of alkanes. Here, to obtain divided carbon, which is black carbon, to make black ink and black painting for polish and car tires. As the equation proceeds on the screen, methane, by heating till 1000 degrees in the absence of air, it gives carbon, black carbon, and hydrogen gas. Another use here is to obtain water gas. As we know, my dear student, is used for reduction of iron ores in the matrix furnace that we took in chapter 1. Here, the water gas is used as fuel also and or reducing agent in matrix furnace. Here the equation proceeds. The methane plus water by heating under 725 degrees Celsius and the presence of catalyst, it gives mixture of two gases, carbon monoxide and hydrogen gas, which is called water gas. Now, my dear students, we are going to discuss some questions on this topic. The first type of question is choose the correct answer. The number of hydrogen atoms in alkane having 4 carbon atoms is what? Is it 5 or 10 or 14 or 12? Remember, my dear student, you have to apply the general molecular formula CnH2n plus 2. So it will be 10. Another point. The number of carbon atoms in alkane having 14 hydrogen atoms is what? Is it 14 or 7 or 6 or 5? Remember, my dear student, to solve this question, you have to put the number of hydrogen atom to n plus 2 equal 14. So we'll get the correct answer. It will be 6. Another example. The molecular formula of an alkane having 12 hydrogen atom is what? C5H10 or C5H12 or C5H14 or C5H8. If you apply the general formula of alkane, you will find that the answer it will be C5H12. Another example here. The number of sigma bonds between the carbon and hydrogen atoms in an alkene having 3 carbon atoms is what? Is it 4 or 6 or 10 or 8? If you answer this question, my dear student, it will be 8. Next point. The number of sigma bonds between the carbon atoms in alkane having 5 carbon atoms is what? Is it 3 or 5 or 6 or 4? If you answer this question, my dear student, and you count the number of sigma bonds, it will be 4. Next point. The number of sigma bonds in alkane having 4 carbon atoms is it what? Is it 4 or 8 or 10 or 13? If you answer this question, my dear student, here it will be 13. That's sigma bonds between carbon and hydrogen and between carbon atoms. Next point. Alkanes are considered from what kind of hydrocarbons? Is it open chain saturated or unsaturated cyclic or open chain unsaturated or saturated cyclic? If you answer this question, you will find that the solution is open chain saturated. The molecular formula of alkane having 6 carbon atom is what? Is it C6H10 or C6H14 or C6H12 or C6H6? If you apply the general formula, it will be C6H14. The next example. The molecular formula for alkane having 16 hydrogen atom is what? Is it C8H16 or C7H16 or C6H16 or C9H16? If you answer this question, you will find the answer it will be C7H16. The next point. The molecular formula of an alkane having 20 atoms is what? Is it C8H12 or C6H14 or C7H13 or C5H15? Yes, the answer it will be C6H14. Next point. Compounds having molecular formula C3H8 is considered from what kind of hydrocarbon? Is it saturated aliphatic or unsaturated aliphatic or saturated cyclic or aromatic? If you apply the general formula, you will find that it will be saturated aliphatic hydrocarbon. Next point. In alkanes, each compound exceeds than the previous one by what group? Is it CH3, C2H5, H3CH2? You will find the answer, it will be methylene group, which is CH2. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.